Hi class, I'm going to leave the warm-up for you guys to do, and you can double check in your notes to be sure that you've got it right. So we'll start off with finding the exact values for these inverse trig functions. So like if I take the arctangent of root 3 over 2, I'm thinking on all of these, try and draw yourself a picture. It's really going to help you out. So on this one, arc sine, I already know that I'm limited to the first and into the fourth quadrant. And then I'm also asking myself, well, where is sine going to be positive? So sine's going to be positive in the first quadrant because all students take calculus, so it can't be down here in the fourth quadrant. So if I think about, well, what's the reference angle? Like what sine of what angle gives me a root 3 over 2? That reference angle would have to be at pi over 3. Here's where it's extremely, extremely important that you guys know very well your unit circle. So if I draw that reference angle in the first quadrant, then this angle here would have to also be at pi over 3. Thus, the arc sine of root 3 over 2 is in fact pi over 3, but you've got to put it down in the first quadrant. So part B, I'm going to have you guys try this one, and if you've done it correctly, then you should end up with pi over 3 for that solution as well. So if I do the arctangent of square root 3, again ask yourself, well, which quadrants is arctangent, like which quadrants can that be in for my range? Well, it can only be in quadrants 1 and quadrant 4. So if I think about, well, where is tangent going to be positive between those two options, then it's going to have to be in quadrant 1 because this is a positive square root 3 there. So I'm asking myself on my unit circle, like what is the reference angle that has a tangent that's the square root of 3? And your reference angle is pi over 3. So how do I know that? Because sine divided by cosine. I'm really asking myself, well, on my 30, 60, 90 triangle, this is how I think about it. So 60, 30, 90, which reference angle am I standing at here so that the ratio, the opposite to the adjacent, is a ratio of 1 to square root 3? And I'm standing then at the 60-degree angle for tangent. So TOA, the opposite to the adjacent, that's the ratio of the sides for the tangent. So that's how I knew that it had to be a reference angle of 60 degrees, but in radians, that's pi over 3. Okay, so when I draw this in the first quadrant then, this angle here is the exact same as what the reference angle is. So thus, this has also got an answer of pi over 3. So arctangent of root 3 gives me the angle measure, pi over 3. Remember that all of these are giving us angles, right? It's inputting the reference or the ratio, and we're getting out of it the angle measure. So this is like asking, well, the tangent of pi over 3 is equal to what ratio? And then that ratio would be root 3. But now I'm doing the inverse of that. So I'm inputting the ratio, and what comes out is the angle measure. So then the arc cosine of negative root 3 over 2, arc cosine is only defined, I can only put it in quadrants 1 and quadrant 2, so all students, now this one's got a negative, so thus I know it can't be in the first quadrant, we're talking about the second quadrant. For arc cosine. So if I'm thinking about, well, here, what reference angle has the cosine of it to be a root 3 over 2? I'm thinking that reference angle here has to be a pi over 6. So then what's the actual angle that it is? Well, the angle to get to that place then must be 5 pi over 6, right? It makes a full pi is all the way across to 180 degrees, but I'm 1 pi over 6 short of that, so all the way across would be like 6 pi over 6. I'm 1 short, so thus this makes this part 5 pi over 6. So thus, the arc cosine of negative root 3 over 2, where is the cosine? The cosine of what angle gives me a ratio of negative root 3 over 2 that's limited to the first and the second quadrant is 5 pi over 6. Alright, so now you guys are going to try this arctangent one. Find the arctangent of negative 1. And if you've done it correctly, the answer should be at negative pi over 4. So double check yourself, make sure you can do that. So if I evaluate functions within functions, so if I take the arc sine of 0.4, and then I take the sine of that, I want to know what value that is. Now, on a lot of these, you might be just tempted to say, well, sine and arc sine, they undo each other, so the answer just must be 0.4. Well, sometimes that'll work, and sometimes that's not exactly the case, so you've got to be careful there. So we remember that arc sine, arc cosine, and arc tangent, I take the arc sine, arc cosine, and arc tangent of a ratio. And then what it gives out to me then is an angle. So this arc sine of 0.4 is giving me an angle. And then afterwards I'm taking the sine of whatever that angle that it gives me. Now it's nice because 0.4 is a number between -1 and +1. Remember, you can only, like, the domain for arc sine is only between -1 and +1. So since 0.4 is between -1 and +1, I know that we're not in any trouble with calculating that. Okay, if it's asked me for the arc sine of, if it asked me for what's the sine of the arc sine of 2, then you wouldn't even be able to compute it. It wouldn't be the number 2, because it's got to be your arc sine can only, the domain is only between -1 and +1. So we're good on that. So in this case, think about this. Okay, draw it out again. I know it's like the answer is going to be 0.4, but I want you to understand why in this particular instance it's 0.4 versus something else. So if I'm kind of graphing here just this portion, and then afterwards I'll take the sine of that. So arc sine is only defined in quadrants 1 and quadrant 4. So since this is a positive 0.4, it's got to be in the first quadrant. Now, where is it in the first quadrant? I don't know. I don't really care, okay? The angle is going to have to be this angle, which will be the exact same as the reference angle. Again, it's really not important here. But if I think about the triangle that this has to make, if I compare it to the unit circle has a radius of 1. And so the ratio, the opposite to that hypotenuse side, will be a ratio of 0.4 to 1. So there's some angle measure here that has that exact number for the sine, that you have to go up 0.4. And then I could figure out what the other number is for the other leg, but really it's again not important. So then I know that, well, if I take the sine of whatever that angle measure is, what's the ratio of the sides that it's going to give me? Well, the ratio of the sides for the sine of this angle is going to be opposite to hypotenuse, will be 0.4 to 1. So in this case, the arc sine, the sine of the arc sine of 0.4 does turn out to be the number 0.4. Let's look at a different example. So the sine of the arc cosine of root 2 over 2. Again, this is giving me an angle. That's the output there. And then I'm going to eventually take the sine of that angle. So what angle has the cosine of it to be root 2 over 2? So if I think about graphing that again, okay, arc cosine, only in the first and in the second quadrant. It's a positive root 2 over 2. So we're then talking about the first quadrant. Well, what reference angle is that? Well, that reference angle is pi over 4, which, being that it's in the first quadrant, that also happens to be the angle. So this is at pi over 4. So if I asked you, like on one of the previous slides, hey, what's the arc cosine of root 2 over 2? The answer would be pi over 4. But now I want to know, well, what's the sine of pi over 4? Well, the sine of pi over 4 on my unit circle is just root 2 over 2. So that's what this sine of the arc cosine of root 2 over 2 is. All right, so if I take the sine of the arc cosine of -1/2, look at it from like the innermost parentheses and then start working your way outwards. This is going to give me some angle measure. I've got to figure out what that angle measure is. What angle is the cosine of it going to give me a -1/2? And it's got to be in the first and in the second quadrant for arc cosine. So since this is a negative in here, that must mean, all students, we are in the second quadrant to draw this. That reference angle has to be, well, where is cosine equal to where is the arc cosine equal to 1/2? Well, the reference angle there is at pi over 3. So how big is that angle then to get to that point in the second quadrant? Well, that angle must be 2 pi over 3. Again, you got to know your unit circle. So since this angle is 2 pi over 3, that's what the arc cosine of -1/2 is. Now I'm asking the question, well, what's the sine of that angle? So the sine of 2 pi over 3, again, you got to know your unit circle, is root 3 over 2. Okay. So I'm going to have you guys try this next one. If you've done it correctly, then the solution here should in fact be 1/2. So give that a go. On part E, arc sine of 2 pi over 3. Don't just assume, oh, arc sine and sine undo each other. Thus the answer is 2 pi over 3. Sometimes yes and sometimes no. Actually, it only technically works if you're in the first quadrant, but you'll see why here. So if I try graphing this, now this time they've switched it up on us. Rather than them doing the sine of the arc sine, they're doing the arc sine of the sine. So this is going to give us a ratio this time. And then I'm going to take the arc sine of this ratio to give me an angle measure. So I'm asking myself, well, sine of 2 pi over 3, what is that? So 2 pi over 3, sine is defined in all 4 quadrants. So this could be in quadrant 4 or quadrant 2 or quadrant 3. Actually, this one, 2 pi over 3, that's in quadrant number 2. Okay, we're not talking about arc sine. Arc sine you can only draw in the first and in the fourth quadrant. Right now I'm focusing only on sine. That can be anywhere. So 2 pi over 3 is not quite a full pi. It's a pi over 3 short of a full pi. So here's our angle measure of 2 pi over 3. But I'm asking myself, okay, all students take calculus. In the second quadrant, sine is positive. So I'm asking myself, okay, well, what's the sine of pi over 3? The sine of pi over 3 is going to be at root 3 over 2. Okay, so this is a ratio of root 3 over 2. And I know it's positive because I'm in the second quadrant, and those sides the coordinates are positive for sine in that quadrant. So I'm asking now the question, well, what's the arc sine of this root 3 over 2? So I'm replacing this. This is all giving me a ratio. So I'm replacing this with the ratio root 3 over 2. And now I'm asking myself, well, what is the arc sine of root 3 over 2? Now that I'm asking the question about the arc sine, I need to draw another picture. But this one, since I'm talking about arc sine, is only in quadrants 1 and quadrant 4. Since this is a positive root 3 over 2, I know we must be talking about the first quadrant. So that has a reference angle at pi over 3. Since the reference angle is pi over 3 and we're in the first quadrant, then this is going to be located at pi over 3. Thus, this is not just, oh, this arc sine and the sine undo each other. The answer is just 2 pi over 3. No, it's not. In this case, it is pi over 3. So be careful with that. All right, on part F, the arc cosine of the cosine of negative 4 pi over 3. Will this be negative 4 pi over 3 or will it be something else? So this is giving me a ratio. I'm trying to figure out what ratio is that. Okay, on the unit circle, if I go to negative 4 pi over 3, where is that located at? So first graph, negative 4 pi over 3, it's negative. So we're going the opposite direction for the angle. So this time we're going clockwise rather than counterclockwise like we have been doing for the positive angles. So negative 4 pi over 3. Well, here's negative 3 pi over 3. I need another pi over 3 more. It's going to be located over there. So this is negative 4 pi over 3. And I went an extra pi over 3 at the end after I went 3 pi over 3. So I already know my reference angle here is pi over 3. So all students take calculus. Okay, I'm trying to figure out the cosine. What's the cosine? If I look at my unit circle, okay, I've got an x point, I've got an x and a y coordinate that corresponds to this particular point. The x coordinate, okay, I'm asking myself, well, what's the cosine of pi over 3? The cosine of pi over 3 is 1/2. Since I'm in the second quadrant, though, this ratio is going to have to be a negative 1/2. So now I'm replacing this with what's giving out to me, which is a negative 1/2, and asking myself, well, where is the arc cosine of negative 1/2 going to be? So when I graph that one, second picture, but now the picture for the arc cosine, I can only draw it in the first and in the second quadrant. All students, oh wait, I've got a negative 1/2 here. Must be here in the second quadrant. So what angle gives me, so my reference angle must be pi over 3. That's where the cosine is equal to 1/2. But since I'm in the second quadrant here, that means this angle is at 2 pi over 3. Thus, the arc cosine of the cosine of negative 4 pi over 3 is going to be a 2 pi over 3. So you guys can go ahead and watch the second part of this video.